But as things change, I'll zoom
You're the
in.
videographer, man.
Okay.
Alright guys. First off, my name is John Moreau with the RD Bitzer Company. I'm going to give you a brief explaining of the drives. You have the same drives on all your locations that we work on in this project. This one being somewhat of the exception. It's the same drive, it's still an HVAC VLT. It's a different configuration because it's a larger size motor. But maintenance, service, repair, operations, all going to be the same. It's just in a different box, basically. Okay. Your main disconnect, your selector switch, and then your actual drive and your keypad and stuff. For the most part, from here down, you guys aren't going to be doing much, unless you got to turn it off for maintenance. Your selector is drive off, auto, and test. Or drive off, bypass, and test. My apologies. It's going to be on, and it's going to be in drive 100% of the time. Okay. Up here, you're going to have either off or auto. Off is just dead stop. It's going to be sitting there waiting for you to turn it back on again. Auto, it will be running, responding to the pressure transducer using the program that we put into it today. You can run it in hand, which will take the transducer out of the circuit, and you'll have to select the speed by hand, just using the arrows up and down to tell you how fast you want to go. You guys got to do maintenance, or if you have a transducer failure or problem. Now you come in one day, the whole building's cold, and they're just sitting here doing nothing, but they're on. Hit the hand, crank it up to whatever speed you think will work for that day. That'll get the heat moving, and then you guys can start doing your troubleshooting and stuff. Okay. Up on the drive screen here, his upper left-hand corner is just a statement of what the set point is. Okay, right now we have them set at 15 PSI differential. You guys are probably going to adjust that over time when you see what your building's going. The middle numbers here, which are currently zeroed out, is the motor amperage. When the motor's running, it takes all three phases, averages them out, and displays it. Gives you guys an idea how well the motor's running based off of, you know, what it should be. And then in the upper left here, upper right, we display the hours. The hours of operation we display there, so you guys can, you know, monitor your maintenance. You can age them together. You don't want to have one motor that's been sitting here for, you know, 6 months and the other one that's been running for 6 months. You kind of want to bring them up and age them together so they wear equally. Your hertz, it tells you how fast it's going. 18 is locked out as a minimum. You'll never get below that. 60 is the maximum. You'll never go above that. You're going to be able to see, just walking past this over the next couple of years, about where it tends to want to live as the building is occupied and unoccupied. Keep that number in the back of your head for the day something does fail. Put it in hand, you put it back to that number. Yeah, everybody ain't going to be happy, but for the most part, you'll be functioning. The bottom lower level here is the actual PSI that is displayed out. Now right now you're seeing a display because your other pump is running. That number will change. You're never going to get, if we set it at 15 PSI, you're never going to sit there dead on 100% 15 PSI, just stay there. There's always going to be some variation. And it's always going to be going back and forth, up and down. Down here at the bottom is auto remote stop. It's stopped because we have it off. The other thing is it can say is auto remote ramping, auto remote running. Ramping means it's getting there, running means it's gotten there and it's happy. Okay. The other thing you can see is auto remote coast. That means something broke. Okay? The drive will sense that there's a problem with the motor and it fears that it will damage the motor or the drive. It will literally just electrically let go of the motor and just let it coast to a stop or let it coast to whatever's happening. And that's where you start to do some troubleshooting. There is a set of fuses in here. There are basic contactors in there. Really the way this works is power comes in, just to extend a contactor up into the drive. The speed is manipulated and then sent back out to the drive, out to the motor. In the bypass mode, it's basically a real hard, non-stop starter. Power comes in here, contactor, out. No control, no nothing. Hard start, boom, go. Run until somebody turns it off. You guys have a redundant pump. You guys have the backup. One of these fails, run your other one. You still have your automation. You still have your varying speed, the system you guys designed and bought for. That's what I normally recommend. If one fails, run the other one, get it fixed. You know what hits the you know what? You put the bypass, and you go. All right. Keep the area around them comfortable. You know, not a lot of excess dirt. Definitely no water. And don't pile anything on them. Don't hang anything on them. If you do got to do some work in here and you think it's going to be really dirty, If you can shut them down, awesome, because there is a fan that will just suck all that dirt and stuff through them. You know, if you're running gas, it's not really a problem. But if you have a big boiler prop or something like that, you're creating a lot of dust. If you have the opportunity to shut them down for the most of the work, shut them down, do your job, and fire them. It'll just save some wear and tear on the drives. They don't like to be excessively hot. They don't like to be over 102 degrees. They don't like to be excessively cold. They don't like to be below 32 degrees. Most mechanical rooms, that's not a problem. If you're comfortable, they're comfortable. Okay. Any questions, guys? Okay. Your pressure transducer basically just reads both suction and differential. What's the difference? It sends a signal to the drive telling how fast to go. Make sure your valves are kept open, except for your bypass. Make sure that's kept closed. Make sure the lines going to the system are kept open, or you get a really confused transducer and it tells the drive to do all kinds of weird stuff. And all the systems other than physical location in your other buildings, it's all pretty much the same. You're going to rotate them back and forth. It's all manual. You don't have an automation system. Like right now this one's running. It's an auto. Hit auto on this one. Hit off on that one. A week or so later, whatever your rotation plan is, do the opposite. One will ramp up, one will ramp down. You never really have a lack of flow in the building. You will have an odd pressure differential for a short period of time. Nobody will ever see it. Okay.
Can you show them how to put it in hand and ramp the frequency up?
The hand, there is a little decimal point kind of hidden there, so move it over to one of these last two positions and just use the arrow up and down. Pick your speed. 20, 21, 22. You can go into the fractional numbers if you wanted to, but really no reason, and then off when you're done. You can go directly from hand to auto. It'll just do again. Once you put it in auto, it'll look at the transducer and say, what should I be doing? And just start doing it. If you're above the speed, it'll just slowly come down to it. If you're below it, it'll slowly come up to it.
Explain the warning lights.
Now, on the side here, on, the little green light will always be lit up. Underneath here is warning and alarm. If the drive senses something it doesn't like, first it'll give you, in most cases, it'll give you a warning. If your current's off, your voltage is funny, it'll go into a warning state. You'll get a description across the bottom here that says warning, and then whatever the problem is. Depending on what the warning is, it'll stay in that state, sometimes indefinitely, or sometimes for a time period. Most electrical things are time period. If you're at a high current, it'll stay at that high current for a while, and then the drive will say, you know what, this is enough. It'll go into an alarm and it'll shut down. Because it doesn't want to damage itself, and it doesn't want to damage the motor.
Is the alarm audible?
No, it's just a blinky light. Blinky red light here, it'll go from warning high current to alarm high current. But they're plain English. They're high current, low current. The low current will just shut down. Phase loss, main phase loss. One that confuses a lot of guys, which probably, let you guys know. There's two different phase loss alarms you can get. You ever see one, read it very carefully. It'll say main phase loss or phase loss. Main means from here to wherever the power came from. Phase loss means from here to there. It'll actually tell you what leg of power is missing. If you see the phase loss thing, hit the info button here, and it'll give you a little, section you can actually scroll down and you can read, and they'll tell you where to start looking for, issues. They use European standards for their phasing out to the motor, so they'll say UV or W, 1, 2, 3. Whereas for the inside, they'll do the same thing, but it's 1, 2, 3, UV and W. So if it tells you, W phase is lost, you lost L3. You pull the cover up here, look at 3, trace it over here, 3, start doing, and then you just go into basic electrical testing, troubleshooting, find out what happened, where'd your power go? Did your contactor burn out, did the wire breaking, did your motor take a crap? That just comes down to, electrical work there. Any of your main ones like that, like phase loss and ground fault and short circuit, stuff like that, have to be manually reset. You have to turn the drive off and on again. A lot of the smaller ones, like the current ones, stuff like that, you can simply just hit the reset button and it'll start back up again. I can't remember exactly every single one that has to have a power cycle. You hit the reset button and it doesn't cycle power.
Just turn it off, turn it back
Turn
on.
it back. Yep, turn it off. When you turn these off, there's a capacitor bank in there that holds power. If you got to go in there and work, turn it off and go grab a cup of coffee. It can take a few minutes to discharge. Also, inside the back of this is a 600 volt DC bus. From here down, sure, work on it. From here up, call Danfoss. The 600 DC volt will block you off that boiler and you won't know what hit you. So I normally tell guys don't screw with it. Even if you can find out what's wrong, chances are getting a part from Danfoss is going to be in the hands. Danfoss service centers are all over the place. If you call for service, chances are they'll have somebody within 24 to 36 hours on site. Number and everything's on the side. You stick it on the side there with their phone number. Material number and the serial number. Give them that. They can walk you through all kinds of stuff. They can help you get somebody out here. Or if it is a part that's something, they can work with you. Most of the time they want you to go through a service center, but for safety reasons, we'll cover your own. We'll cover them. But keep them clean, keep them dry, keep them happy. You're not going to mess with them much, guys. Other than rotating them.
Follow the alarms, huh? If you're in the
If you have an alarm, just follow the alarms, yeah.
hit the info button. What's main menu and quick menu?
Main menu and quick menu are things that normally I tell guys not to mess with. For the application you guys have here, you're barely scratching the surface of the ability and the logic in the drive. If you go into the main menu and start pushing buttons, you can change a parameter that may change 2 or 3 in the background. Well, hey, that didn't fix the problem. I'm going to put that back to what it was. There's 2 or 3 in the background, don't always go back. So you can end up with a really screwy program at that point where nothing's going to work. So try to avoid pushing buttons. One button you can push, Carlos will show you. Quick menu, it says my personal menu. Hit OK, and that's your set point. Hit OK again, and use the arrows, and that's how you change your set point. If right now, if the current 15 pounds ends up not being what works for this building, once you make your decision to change it, hit OK, and it'll go back to it. You can hit status to go back to the main screen, or if you walk away for a little while, get back to the main screen.
So if the system isn't getting enough heat to this building, they can bring that up.
They can bring that up, yes.
And what is the max on the PSI?
It's a 0 to 50 scale
And
transducer.
You know the system. What's don't go past what? 20?
You're only getting past 60
You're only
hertz.
you're not going to. You can set it to that 50-pound max.
Oh.
But the pump, you only have 60 hertz of speed, so the pump will actually speed will actually hit maximum speed before it'll necessarily get it. So.
Can you switch them over, and I'm going to let that change out. So you hit on, then you turn that one. You hit auto.
Auto, which is auto on. That one's going to ramp up. The other one's going to ramp down. They're not a incredibly fast acting, and it's by design. It's the way we have it programmed. If we program the controller too quickly, you end up overshooting and then undershooting, and you're really kind of searching with a large number of apartments and not really big valves with high volume. With them opening and closing, I'd rather have them kind of go a little slower. It's better for the pump, it's better for the motor than to be constantly up and down and up and down. What you'll probably find is the motor will find that sweet spot. You're not going to come down here one day and it'll be at 20 hertz, you come over the next day it'll be at 50 hertz. I don't think you're really going to have a massive, huge swing like that. You normally find it's actually a somewhat small swing between everything. Because half your building's open, half your building's closed, quarter of your building open, another quarter of your building closed. Just the size of a building like this.
When we walked in here this morning, was it set at 15 PSI?
No.
They were on manual? No, what were they?
They were running in hand just at a generic speed.
Okay. So we don't know what the actual PSI should be for this building.
We don't know the design. There was no designed pressure differential given to me.
Right.
So that's why I'm saying the 15 PSI is just kind of an educated guess. And, these guys and you guys are going to have to kind of fiddle with that until you get what works for the building.